Hi Professor, in this video we are going to show you the procediments from the problems of homework 1, and I'm going to start with the problem 19. In this problem we have the force, the resultant force that is given us by the problem. So in this problem we have to calculate the force Fi and Fb. In this problem, I used the parallelogram method, and now I'm going to show you the procediment. So now we have the problem here, and this is the problem that we have to calculate. The problem gives us the resultant force that is 950 newtons, and that we have to do is to calculate the force A and the force B. But how? So we know that force resultant is equal to force A or plus force B. So normally if we want to calculate the resultant vector, we have to sum the force A and force B. That is this is equation. But what happens if I have the resultant and I want to calculate this force and this force? So it's the same. We have to do the operation, but in the against way. We have to remember that resultant force is given us by the sum of Fi, the force A, plus force B, and this is the equation for calculate the force Fi and Fb. So you have a normal operation or problem if we don't have the resultant force. We do these sums, and so summing all these forces we get the resultant force. But here we're going to do the opposite way. So if I do this operation in my calculator, we know that I have 892.7 newtons, and for force B we get 324.9 newtons. And what that means, that means that these newtons, this vector is the magnitude of Fi, this Fi, and this newton is the magnitude of this Fb. So now here we have the first Fi, the force A, and this force A is this. Now we are going to calculate force B. So for calculate the force B, we need to know what is the angle theta. And remember that we are using the parallelogram method. So I draw here a parallelogram, and this is representing this. So if in the parallelogram we have 20 degrees, remember that each corner we have 90 degrees. So that is represented here. This is a corner by 90 degrees. So it's easy to calculate theta. Is use a subtraction for 90 for minus 20, and we get 20 degrees. So as we did in the last to calculate the force A, we're going to apply the same thing here, that we know that force resultant is equal to the sum of force A and force B, and here is represented by this. We know that this is the force B, that is this one, and here we have the force A, but the difference here is that we don't know this, but we have the resultant force, and here we can apply the trigonometric basis. So knowing this, we are going to use the trigonometrical function to calculate this force. So now we already write the equation to calculate force A. We know that we use the trigonometric function for cosine and use only to change this for this. And finally, we have the equation despite, and we know that force A is equal to 915 newtons divided by cosine of 20, that is equals to 1011 newton. And this force is this one. And now we have to calculate force B. How? With Pythagoras. So now we have the force A, that is 1011 newtons, and we have to calculate force B. How? With Pythagoras, as I said. So we know that force A is the hypotenuse of this triangle, and the another side is the side that sums and equals to the hypotenuse. So this is, I already made the equation. This is a normal equation for Pythagoras, but we have to clear to find a force B, and finally we get this clearly for FB. And just we need to solve this simple problem. We can use the calculator. And finally, we got that force B is equals to 345.9 newtons. That is this force. But in our first triangle is this force. This force is equals to 345.9 degrees. But we have a problem, because in the problem, the problem says that we have to use, or we have to get the minus force for force B. And what is that force? Remember that to calculate this, we get the force B, and this is the minus. So we are going to use this force, because this force is more bigger than the other. So for finally results, we have the force A is equal to 892.7 newtons, and the angle theta is equals to 70 degrees, and the force B is equals to 325 newtons. So this is the problem for problem 19. Thank you.
Hello, today we're going to talk about vectors, specifically the problem 245. It reads, if the resultant force acting on the bracket is to be directed along the positive x-axis and the magnitude of F1 is required to be a minimum, determine the magnitudes of the resultant force and F1. As you can see, we have a graph explaining the problem that we have to elaborate. So, all you have to do is go to a piece of paper or whatever and draw a graph, which you can put all the information you need and make it easier for you to understand what you have to do. But to make things easier, I've already made one, which is right here. As you can see, all the information is right here. There's everything you need to know according to the image, the picture we have here. So, now that you have everything right here, you're gonna have to do a lot of exercises now. As you can see, the next step is grabbing all the F1s, all the Fs, which is F1, F2, and F3, that they have their values. As you can see, we have two triangles here. We have a degree right here, which is theta, F1, F2, and F3. Now, we're gonna grab F1, and F1x, using the x-axis, equals to F1 cosine of theta, and F1y equals F1 sine theta. We're gonna do the same thing with every single one of them, f1, f2, and f3. As you can see, f2x in the x-axis equals 300 times 4 for this. I'm really sorry. And these operations will give you a result, which is this. Now with f3 you do the same. You grab the information you have here. As you can see, it's 260 minus 260. Why is it negative? Because it's under the x-axis, which causes it to be negative. Times this, which is the triangle here, right here. You do Pythagoras, and you have your values right here. Now you take your values here, and f1, it's f1 cosine of theta I plus f1 sine theta j. I just added this so it's easier for me to understand, because I don't want to use x and y respectively in this moment. So I just added I and j. f2, 240 I minus 180, and f3 minus 100 minus 240. So this is easy. You're gonna have to grab the values that have j or I, and you're gonna operate the values. You're gonna have to have your evaluation at the end. So this is the resultant force. It's I, the resultant force, times I plus j. So you do this, f1 sine theta minus 180 equals 240, minus 240 equals 0. And f1 sine theta, you change, well, of course you have to put it in right here, and you have 420. Thus f1 equals 400 divided by sine theta. The j component, and the I component, I'm sorry, this is the j component right here. We grab this, as you can see, 180, it's right here, and 240, it's right here. Now we do this with the same values that we have here. I component, and you do this, and it's gonna give you a result. So we can conclude that f1 is minimum when sine theta equals 1 or theta equals 30 degrees. Thus f1 equals 420 pounds, and the okay, see, and the resultant force equals 140. And this is it. That's the end of the result. That's your final solution. This is the result.
Hello, good evening. Today I'm going to explain you all the exercise to 112 of homework 1 of the physics subject. The exercise says, determine the project component of the force AV equal to 560 newtons acting along cable AC. First, we analyze the plane. The point C, which respect the axis Z, is 1.5 meters. The point C, which respect the axis X, is equal to 3 meters. The axis X which respect the point A is equal to 3 meters. The point B, which respect the axis Z, is 1.5 meters, and respect the axis X is 1 meter. The force AB is equal to 560 newtons. Then we find the points where each vector originates and ends. This is the coordinate of the vectors of the point of the vectors. We understand that RAZ vector is equal to R0Z vector minus R0A vector, and RAB vector equal to R0B vector minus R0A vector. So this will obtain doing this formula. RAZ vector is different to RAC. So RAC is equal to the root of R0Z minus R0A at the same of the RAB. To realize the before formula, you find the UAV and the UAZ. Respectively doing, it will have each of the answer expressed in Cartesian vector. This answer is first this, and this answer is equal to this in the Cartesian vector. We'll multiply the force AB. This force is equal to force AB multiply to UAV. This is equal to 560 times UAB. This result. The result of FAB is equal to this. To finish, the result of the previous multiplication will be multiplied by AC, and the way B will be obtained the projection. The formula of FIB multiply AZ is equal to FIB multiply UAZ, and the result is this. So the project is 346.67 newtons. So this all, and thank you very much. Hello, good evening. Today I'm going to explain you all the exercise to 112 of homework 1 of the physics subject. The exercise says determine the project component of the force AV equal to 560 newtons acting along cable AC. First, we analyze the plane. The point C, which respect the axis Z, is 1.5 meters. The point C, which respect the axis X, is equal to 3 meters. The axis X, which respect the point A, is equal to 3 meters. The point B, which respect the axis Z, is 1.5 meters, and respect the axis X is 1 meter. The force AB is equal to 560 newtons. Then we find the points where each vector originates and ends. This is the coordinate of the vectors of the point of the vectors. We understand that RAZ vector is equal to R0Z vector minus R0A vector, and RAB vector equal to R0B vector minus R0A vector. So this will obtain doing this formula. RIC vector is different to RAC. So RAC is equal to the root of R0Z minus R0A at the same of the RAB. To realize the before formula, you find the UAV and the UAZ. Respectively doing, it will have each of the answer expressed in Cartesian vector. This answer is first this, and this answer is equal to this in the Cartesian vector. We'll multiply the force AB. This force is equal to force AB multiply to UAV. This is equal to 560 times UAB. This result. The result of FAB is equal to this. To finish, the result of the previous multiplication will be multiplied by AC, and the way B will be obtained the projection. The formula of FIB multiplied AZ is equal to FIB multiplied UAZ, and the result is this. So the project is 346.67 newtons. So this all, and thank you very much.